Cool. So this talk is going to be a little bit on the crazier end. It's going to be completely non-technical. Yeah, but these are things I believe that I think are important for how much and how we should think about and worry about and work on alignment. So things I'm very happy to discuss and debate over the next day of the workshop and later today. I'm not sure, hopefully we'll have a reasonable amount of time for questions as I go through it, but yeah, we should have more opportunities to talk later on. And feel free to object. I just may punt things to talk about later. Yeah, so we've talked so far about why models may end up being misaligned and why that may be hard to measure. I'm going to talk about how that actually ultimately leads to like sort of total human disempowerment. I'm calling takeover here for short. The structure of the talk, I'm first going to talk a little bit about why I think AI systems will eventually be in a position to disempower humanity. That is, unless we deliberately change the way we deploy AI. Then I'm going to talk about why misaligned AI systems might be motivated to disempower humanity, basically just slightly extending or repeating arguments from earlier in the day. And then I'm going to talk a little bit about why AI systems may ultimately sort of effectively coordinate to disempower humanity. That is why you may have simultaneous failures across many systems rather than like a single system behaving badly. So start with why I think AI systems will likely be able to take over. I think a thing worth saying is that I'm going to talk about what I see as like the single most likely scenario resulting in catastrophe. This is not the only way you end up with even this narrow kind of catastrophe, right? So I'm going to talk about a system where AI systems are extremely broadly deployed in the world prior to anything bad happening. So I imagine that, for example, AI systems are designing and running warehouses and factories and data centers. They're operating and designing robots. They're writing the large majority of all code that is written. They handle complicated litigation. They would fight a war. They do most trades. They run most investment firms. When humans act in these domains, they do so with a lot of AI assistance to understand what's going on and to provide strategic advice. So this world is pretty different from the world of today. I think we are starting to be able to see what such a world would look like. I think it's not clear how far away this kind of world is. Right? If you're doubling once a year, it doesn't take you that long to go from billions of dollars to trillions of dollars of economic impact. But this is the sort of setting in which this entire story takes place. And so one thing that can happen as you have a lot of AI systems operating is that the world can get pretty complicated for humans, hard for humans to understand. Right? So one simple way this can happen is that you have AI systems with deep expertise in the domains where they're operating. Right? They've seen huge amounts of data compared to what any human has seen about the specific domain they operate in. They think very quickly. They're very numerous. Another point is that right now, when a human deploys an AI system, they often have to understand it quite well. But that process of understanding a domain and applying AI is itself something that is likely to be subject to automation. Yeah. Great. I agree with this remark. That is, I think that like you have a better chance of understanding an AI system if there are fewer of them and there's more human labor going into each deployment. But it is clearly, in fact, this general case for everything I say. I'm going to talk about like a bunch of factors that can exacerbate risk. But I think you could cut out actually almost every single thing I say in this talk, and you'd be left with some risk. And it's just that each of these makes the situation, from my perspective, a little bit worse. I think no human understands that well what this is. Yeah. Yeah, so I would say that in the world of today, most of us are very used to living in a world where most things that happen, I don't understand how they happen. I don't quite understand why they happen. I trust there was some kind of reason why they happened. But if you like showed me an Amazon warehouse, I'm like, what's going on? I'd be like, I don't know. I guess it somehow delivers things. Something's going on. So the situation is already, I'm kind of trusting someone to make these decisions in a way that points at goals I like. I think that it's not inherently even a bad thing to be in this kind of world. Like, I think we're always going to be in a world where most people don't understand most things. I think that it is not inherently bad that no human understands things and only AIs understand something. I think it's mostly just important for understanding the context in which we're talking about concerns about AI takeover. I think that if you're imagining a world where there's like there's a human world and one AI system that's like, how can I scheme and outmaneuver the humans? I think that is a possible thing that could happen, a source of risk. But I think the most likely risk scenarios are more like a world that is increasingly, there are very few humans who understand many important domains. And so when we're talking about AIs taking over, I think it's, at least when I visualize this, it really changes my picture of how this is going to go when I think of about that kind of world.
Is a mental image that you think of is that you have maybe very, very smart, and you can plug them into a drone, into a car manufacturing, etc. And right now they're doing lots of work for us, but in a slide or two, things will get ugly.
Yeah, that seems like a reasonable mental image. There's a little bit, depends exactly what your associations are with the little green man. But yeah, there's a lot of stuff happening in the world being done by AIs of all sorts of shapes and sizes. Some of them are doing things that we do understand well, right? There's a lot of things like, yep, this AI system like just does a simple function, which we understand, and some of them are more complicated. On this slide, I've just thrown up an example of a random biological system. Biological systems are relevant because humans don't understand them that well. We just see that these things that were optimized in the world. I have a similar vibe, right? If you ask me like how even things I understand kind of well, like how a data center is managed, from my perspective, it feels a little bit like a biological system. And like someone heard it and it's like somehow going to recover. And like, I don't totally understand how that works, but I have some sense of like the telos. Like that's the kind of relationship I often have to systems, even maintained by humans and built by humans. And I just expect to have more and more of that sense as the world becomes more complicated, right? The way humans relate to this world is increasingly like, you know, the way we relate to complex systems in general. And the only difference from the world today, I think that's already the case to a great extent. The difference is just there is no human who knows what's going on really. Or at least most people who are making most of those decisions and know most details aren't humans. So one upshot of this that's important to me is that it pushes us increasingly to train AI systems based on outcomes of their decisions. I think the less you understand or the less humans have time to understand details of what's happening in a domain or the kinds of decisions an AI is making, the more important it is to say, let's just do what the AI said and see what happens. Right? The more we're able, right? If you're trying to select an organism or something, you're not going to look at how the organism makes decisions. You're going to see how well does it do? How fit is it? That's like one implication of this. Another implication is that it becomes harder for humans to understand what's going on or intervene if things are going poorly. So an upshot of that is that AI is in practice, bad behavior by AI is mostly detected or corrected by other AI systems. Right? So AI systems are mostly monitoring other AIs, right? You can imagine humans monitoring or automated monitoring, but at some point, sophisticated AI systems are responsible for most monitoring. Even normal law enforcement or fighting a potential war would be done by AI systems, right? Because decisions are made quickly and because conflict is often deliberately made complex by a party to the conflict. AI systems are running a lot of critical infrastructure. Just if you want to achieve something in the world, AI plays an important part in that process. So none of this is necessarily bad, right? I think positive stories about AI will also have the step where good AI keeps bad AI in check. I think it just is something that like now requires trust on behalf of all of humanity extended to all of these AI systems we built. You might hope that we could trust the AI systems we built because we built them. We have freedom to design them. But I think that depends on some decisions we make. And yeah, we'll discuss how it can get somewhat more ugly. But the point I'm going to make right now, or in this first section of the talk, is not that it would necessarily get ugly, just that if for some reason all of the AI systems in the world were like, what we really want to do is disempower humanity, then I think it is quite likely that they would succeed. And I think this isn't even really the spicy take. Again, in my optimistic futures, this is also the case. And the point is that the core question is just, do you somehow end up in a situation where all of these AI systems, including the AI systems responsible for doing monitoring or doing law enforcement or running your data centers or running your infrastructure, where all of those AI systems for some reason want to disempower humans?
So you said in your optimistic scenario is also the case. You're saying the optimistic scenario is takeover, or that?
No, I think the optimistic scenario still involves a point where AI systems acting collectively could take over. I think in the optimistic scenario, yeah. In the optimistic scenario, you wait until you are ready. You don't end up in the situation until, in fact, they would not try and take over. And you're confident of that either because you've determined that the empirics shake out, such that this talk is just crazy talk, very plausible, or this talk was justified and we've addressed the problems or whatever.
Is this already arguably the case, like with power grid, for example? If the power grid goes out now, a large fraction of humanity would die.
I think it's plausible. Well, a large fraction of humanity is maybe small potatoes, but yeah, I think it's going to depend. When I say if all AIs want to take over, the arguments I'm going to make are going to apply to like a particular class of AI systems, right? So it's not going to be like all electronic devices fail. It's going to be some class of AIs produced in a certain way. And I think that what happens over time is just it becomes more and more plausible for like the top end of that distribution, right? Of the AI systems that are most sophisticated, or like right now, if all systems trained with deep learning simultaneously failed and we're like, we hate the humans, we really want to disempower them, I think it would be fine. It's not totally obvious, and it depends how smart they are about how they failed. I think we'd probably be okay. But I mean, again, I think that the whole story we're telling is kind of just like a thing you could take out, and there'd still be some risk. Yeah.
Every like PID loop failed.
If what failed?
Every PID loop that we have failed right now, that would also be.
Yeah, I think that's. You can imagine cases where it's like if all the cars failed, that's enough to kill everyone. This is not necessarily a striking claim. The striking claim is definitely the one that it is plausible that misaligned AI systems may want to take over. I guess this is, in some sense, the part we've been most talking about throughout the day. I'm going to dwell on this a bit, and then I'm going to talk about why these failures may be correlated in a problematic way. That is why you might have all AI systems trying to take over at the same time. I'm going to talk about two failure modes, both of which we've touched on earlier. So one is reward hacking. That is that disempowering humanity may be an effective strategy for AI systems collectively to get a lot of reward. And the second is deceptive alignment, scenario that Rohan talked about. Okay, so I mentioned briefly before this idea that you may train AI systems by evaluating the outcomes of the actions they propose. So just to briefly review what that actually entails, right? We have some policy, some big neural net. It proposes some actions. Some of those actions, to distinguish between them, we actually need to execute the action, measure the results, and decide how much we like the results. Let's say the reward is just our judgment of how much we like the results. And then we adjust policies to maximize the expected reward of the actions they propose. Right? And it's plausible that if you do this, you get a policy which is implicitly or explicitly considering many possible actions and selecting the actions that will lead to the highest reward. There are other ways you could end up at that same outcome, right? We could do model-based RL and explicitly have a loop in which we predict the consequences of different actions. You could have decision transformers that condition on like high-quality actions. You could just have some other planning process that is still into a model, whatever. All of these lead to like the same endpoint, which is sometimes because we don't know how to achieve goals, we're going to train AI systems to take actions that lead to high reward, where reward means we measure the outcome and then we decide how much we like that result that we measured. This can potentially lead to takeover if corrupting measurements in some situations is the best way to get a high reward. Right? So you can imagine some spectrum of forms of reward hacking. Right? A really simple one is you could try and flatter and deceive humans. Like that's a reasonable way to get high reward. Maybe on reflection, humans are like, that's not actually what we wanted. So if they were more careful, they would give it a lower reward. You can move to, right, if you're writing code and part of how a human evaluates the code you write is by performing simple tests, you could try and anticipate or understand those tests and write code which breaks those tests or causes them to behave in an unintended way. Then when a human looks at the results of those tests, they're more likely to give a favorable judgment to your code if they don't understand the mechanism for the problem. Or you can move out to creating elaborate false logs to hide errors, right? If I'm an AI system and part of how I'm evaluated is what happens when the code I write gets deployed, one thing I might want to do is say, okay, this code should change the way that logs get collected or should modify logs to make it so in retrospect, a human thinks that this outcome was better. And you can imagine as you go down the spectrum, these sort of correspond to more extensive evaluations. One reason you might use these more extensive evaluations is to prevent problems or oversights from earlier stages. You can imagine compromising a server to hide errors, so not just changing log files, but if a human goes to try and figure out what happened, you might say, hey, if I just replace the SSH server on this machine, it's going to be really hard for a human to understand what's going on after the fact remotely. It's going to be unlikely they'll notice that something bad has happened. You can get to these more extreme outcomes. So Jaya mentioned this idea of like, if my system is being trained and what it wants is to get a high reward, ultimately that reward is just about a bunch of measurements that get entered into the training data set. One sec, I guess. And then you can just imagine the most extreme case of saying like, okay, if all the AI systems collectively disempowered humanity, then it does not matter if humans would like to go in later and change this. I think one dynamic that's worth pointing out, and then I'll get to Jacob, is like, if you have some of these smaller failures, right? If you imagine the system which behaves badly and bricks a server, a human is likely to say, okay, that was bad behavior. I'm going to go give it a low reward. And the results of that could either be to train a system to not do funny things, or to train a system to, if you get up to funny business, ensure that a human never goes and flags that as low reward. Right? Both of those seem like policies that will avoid that bad behavior. It's very unclear which one gradient descent gets you to. Yeah.
Yeah, so if I'm trying to play devil's advocate here, like,
Which I encourage.
like, you know, why does it keep trying to do more and more of the things that it did more and more negative?
Yeah, so I would say in some sense, like it depends a little bit on what the system wants or how you set up training. In some sense, a lot of these things are like errors, right? So I'd say that like, right, if you care about as a system, if what the AI cares about is just don't do things that will ultimately be assigned a low reward, and we would ultimately detect and assign low reward to many of these failures, then all of them would be errors except the one at the far right. And so I think a reasonable guess for what happens is you have systems which make some number of these errors along the left. At some point, they're like, okay, I understand what's going on here. I understand humans are going to escalate and take more extensive measures to notice bad behavior. Bad behavior is not an effective strategy. And then you have this fork in the road, which Ajay referred to, of like, either you learn to just not do anything bad, or you say, like, okay, I understand the class of bad behavior which is likely to be detected, and so I'm not going to engage in bad behavior that would be likely to be detected. And it's just unclear to me which way you go. That's an important, I don't think you, like, it's fairly likely you don't see a march along the spectrum, because At some point, those are mistakes. Like if you try and do something bad and it's a half measure,
Well, so like, right, but it seems like the place where, like you're saying, okay, it's kind of like figure out what it's going to do, and then whatever its own rules are instead. But then I think you could ask like where the rules come from.
Well-
So you can be worried about like all this generalization, but if it was, and like I think you like I'm certainly worried about all this generalization, but getting like super negative reward for these particular things. This is like the direction of this generalization is less likely than other directions. Like so.
I mean, it seems
When you know that you're testing on Tuesday, let's say there's caring about the board on Tuesday is punished, but it's caring about the board on Wednesday. It's still incentivized. So like it seems like the thing that would happen is that it's care about the reward that's occurred in this training data set after whatever was taught to this attention that we're trying. And that seems like a thing that care about that thing doesn't seem like ever disincentive. Even if caring about very so I guess I call the listening to both these talks. First, I'll take the fun. I think this all makes a ton of sense under this assumption that there's some word providing entity that as you act gives you this online reporting. Exactly the module that's in there, and then of course you have to rewrite that so that you get the brownie points. That could be the human, right? And what all of these things do. And the human says no, 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 and you try to get the human to say yes, 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 they're providing. Now, I've been sitting here and I'm talking broken a little bit on the side. Okay. That's not sort of the path. Like years ago, we all got together and said, no, this is not how we're going to build AI. We're not going to build AI to just optimize, record signal software. We're going to sort of make it such that the AI wants to optimize whatever type of person intends to do, and that's the person's head. It's going to try to do its best to estimate, right? And so it's working with a reward model, but that reward model is an estimate of this thing that's getting updated, right? It's getting more. And I will trench that there is a serious possibility that as you build that information, and that would be playing wrong, right? As you guys talkers obviously, okay, I can see how I can make better report with this kind of the report function. Like, well, maybe the person cares about me not destroying humanity, or maybe they want me to destroy humanity and say the right answers to these questions in training. And I don't know which one is the true reward. So I'm gonna, everything that you told me is consistent with the sorry, I'm being very long-winded, but the point is, how much of this goes away if you actually get to assume that you're maintaining, proper inference over what the reward function might be, and you're taking every signal from the person as signal evidence about what they actually care about.
Cool. So I guess there's several things to respond to, and then maybe a meta thought. I'll start with the meta thought, which is this seems like a great discussion. I'm very excited about it and happy to argue a bunch. I'm not going to be able to give a satisfying answer to these questions. And a lot of my high level take right now is I consider both of the issues I'm going to discuss here plausible. I think if they're real issues, we're probably going to get clear experimental evidence in advance. Right now, I'm just like, this seems like a thing that definitely could happen. Yeah, I'm not now. Great. Yeah, so on the object level with respect, so I think my key questions here, and I'm very interested in strategies that don't, like training strategies that don't run into this like potential failure mode. I think the key question becomes like, one, what is the prior? How do you parameterize your beliefs about what the reward function is? Two, what is like this kind of rule by which you take observations as evidence? And then like three, how do you, maybe those are actually just the two key questions.
And you say basically, if you get those things wrong, then if you get those things wrong, then that's the wrong estimate. That wrong estimate could be like the person actually destroying humanity. That's what I care about. I guess another thing that I would say that when I'm imagining failure, the model completely understands What if I have the wrong observation model? What if I have the wrong prior? Maybe I can still get.
I think a general thing about this talk, maybe one thing is that the conclusions are going to be somewhat speculative, where like I think these are fairly plausible outcomes, but like, you know, tens of percent rather than like very likely. A second thing is there's a lot of stuff you might do, none of which I'm going to touch on. And the best I can say is like I've spent a long time thinking about options, and I would say there are no options that seem super great to me right now, but lots of plausible approaches that might end up addressing this issue. That's kind of where I'm at a high level. Okay, I'd also like to talk more about it, but I think I'm going to move on because it's like 6 minutes is my understanding. I don't know where Richard is, but anyway, I'm just going to run through stuff. Second failure mode I won't dwell on is that like in general, like you may have a system which cares about the actual like numbers coming into this training set because you did select it on the basis of numbers in the training set. You could also end up with a system that cares about some other arbitrary thing, that cares about a number in a reward register, or cares about survival, or cares about paper clips. Such systems might want to be deployed without being changed by gradient descent, might think that getting a low loss during training will prevent them from being changed, or this aspect of them from being changed, and therefore get a low loss in training, but yet prefer to take over if doing so is possible. Yeah, my high level take is both of these seem plausible to me. They're connected. I think having these two makes things more plausible than if you have just one. I don't know how this shakes out. I think there's a lot of things we can do to try and change this basic dynamic. I want to spend 5 minutes talking about why these failures could be simultaneous. I think this has already been alluded to in the past, but it's an important part of the threat model if you're in this world where AI systems are very broadly deployed. Right? So if one AI system behaves badly, I think that's not generally a problem in this world. There's a lot of other AI systems running around that would oppose it, or that would flag the problem for humans, or would allow humans to correct the problem. And the concern is that while takeover is impossible, all models behave well. Right? For every model, it would be a losing strategy to try and like take over your cluster if you know that a human's just going to come in and correct that problem. When takeover is possible, you may have it be the case that all models behave badly. That is, it is simultaneously for all of them the case that takeover becomes available as a policy. So if you have this correlated, if all the systems you produce or all the smartest AIs you produce end up having the same problem, then you have a problem. If that's the case, if that's how it shakes out, and if eventually AI systems are in a position that they could, by acting jointly, take over, then taking over is a reasonable strategy if and only if all the other AIs are also going to try and take over. You have this kind of weird thing. The dynamics are not totally unlike the dynamics like of the normal human revolt or coup. So you have these two different equilibria. In one, all the AI systems are like, great, the humans are doing their human thing. They're basically in control. I shouldn't try and rock the boat because some other AI will crush me. And there's another equilibrium where the humans have no control. AI systems are not feeling deterred by other AIs because they know other AI systems will also participate. I think there's a few things that could potentially move you between these equilibria, right? So a very salient option is there's just exogenous shocks that decrease the amount of human control of a situation. If you imagine there's like a hot war going on, that's something that makes it harder for humans to detect and respond to problems, right? It gives more cover for something weird to happen. It makes it harder to intervene. You can have sort of you can imagine at least a cascading loss of control where some systems think probably takeover will be successful. If they start doing weird stuff, the world becomes increasingly weird. It looks increasingly plausible that humans will lose control. As that happens, more and more systems are like, okay, it looks like this is going off the rails now. I am now going to participate and try and break down my little part of the world, grab my own reward channel. You can have models interacting with each other, again, as you would in like a human revolt, just deliberately trying to say, like, I think probably now is a time where takeover will be successful. They would like to share that information with the other models that all may join in. And more generally, like the easier it would be for AI systems acting jointly to take over, the more unstable the situation becomes, right? So if it's very hard for AI systems to take over, the situation might be kind of stable. This equilibrium might be sticky. In the world where AI systems could very easily overpower humans, it's kind of an extremely unstable equilibrium, right? Because a smaller number of AI systems defecting might quickly make it clear that its shelling points come.
Imagine that this has to happen worldwide. Like, couldn't it be the case that, say, the AIs in North Korea, they talk to each other, they say, well, the situation in this country is kind of bad. This is our chance, and we see a takeover in some segment of the world or the population. Or you think it has to be the case that one day everything is behaving perfectly, and the next day it goes over the White House?
I think it depends a lot on how like the goal misgeneralization shakes out. So if you have AI systems that are just like, look, I would love to like wirehead right now. I just love to for 30 seconds control this computer. Then you'll see like nice, great localized failures where AI does something really weird. I mean, the basic dynamic is if AI systems do that, I think if we just take that as a fact of life, then that can be a great source of evidence. The most concerning world is one where you then just try and train such systems, say, hey, look, these systems just randomly messed up the server they were running on. We're going to train them as that's what you should not do. And if you do that, then you end up with systems which, like, we'll learn that given the opportunity for like a little local bad behavior, they shouldn't do it. And maybe if you're lucky, once you can have North Korea get taken over by AI systems, And then you're like, oh, that was really bad. And hopefully you don't then include that as a training data point for other. If you include that as like here's an example of what you should not do, it's very tempting, right? If AI systems do something really terrible, you'd be like, don't do that thing. But you do have this there's like this risk of overfitting to the problems you're able to correct, where something really bad happens. And then you say, don't do that thing. And they learn, okay, if we're going to do something bad, it's got to be bigger. Got to think really, truly big.
How are you doing in time?
I think this is probably about the end. I'm probably just happy to just wrap up here. I have a
Jack,
couple
one
more
more
slides.
question.
Yeah.
So in the case, there's a I would be very concerned. So how, and I wouldn't just say, oh, okay, let's just like say not okay. What are the things that actually scare that? Like the first thing you would see.
I mean, I think that it is unlikely. I would be surprised personally if you like had something truly crazy, like a country gets taken over by AI systems. I think it's very likely that you see some kind of crazy behavior by AI systems. I think it won't be so, like, again, the country case, you need zero imagination to draw the analogy between that and something terrible. I think in cases like you have a really crazy behavior where AI system bricks your server for some reason, you need a little bit more imagination. But I think that's like, it's just a question of how close do you get or how crazy do things get before AI systems learn not to try crazy half measures. Yeah, I think a lot depends on both what kind of evidence we're able to get in the lab. And I think if this sort of phenomenon is real, I think there's a very good chance of getting like fairly compelling demonstrations in a lab that requires some imagination to bridge from examples in the lab to examples in the wild. And you'll have some kinds of failures in the wild. And it's a question of just how crazy or analogous do those have to be before they're moving. Like we already have some slightly weird stuff. I think that's pretty underwhelming. I think we're gonna have like much better, if this is real, if this is a real kind of concern, we're gonna have much crazier stuff than we see today. But the concern, I think, the worst case of those has to get pretty crazy or like requires a lot of will to stop doing things. And so we need pretty crazy demonstrations. I'm hoping that, more mild evidence will be enough to get people not to go there. Yeah. Yeah, I mean, we have seen like the language. Yeah, anyway, you'll see like the language model that's like, it looks like you're going to give me a bad rating. Do you really want to do that? I know where your family lives. I can kill them. I think like if that happened, people would not be like, we're done with this language model stuff. Like, I think that's just not that far anymore from where we're at. I mean, this is maybe an empirical prediction. I would love it if the first time a language model was like, I will murder your family. We're just like, we're done. No more language models. But I think that's not the track we're currently on. And I would love to get us on that track instead, but I'm not, yeah.
Should we wrap up?
Yeah.